Now I want you to look at this video very carefully. You will see that there is a difference between the true heading and the grid heading. And the grid heading is about 1 degree more than the true heading. But why? What does that mean that the grid heading is more than the true heading? Forget about 1 degree. 1 degree is the convergency. Sometimes you will find that your grid heading is about 1 degree less than the true heading. So how do you know where you are? If you have seen one of my previous videos, I have described about the grid heading and true heading very nicely. I hope you can check out this video here after you have seen this video. So today in this video, I am going to tell you a very easiest way, a visual way to find out where my grid heading is going to be more than the true heading and where my grid heading will be less than the true heading in Northern Hemisphere, and also what will be my grid heading and true heading in the Southern Hemisphere. So let's start. Remember, everything is about Central Meridian. So this is your Central Meridian, no matter in what zone you are in. So I put this Central Meridian like that, and I put my equator here. So this is my equator and this is my Central Meridian. And Central Meridian of a zone in a UTM zone. So in an UTM zone, there has to be a boundary on the left hand side of the Central Meridian and on the right hand side of the Central Meridian. Okay, we all know that. And they are not straight lines. Only thing that you need to remember, the zone boundaries are not straight lines. They are curved lines. So how they are curving? They are curving from equator towards the Central Meridian. Here also from equator towards the Central Meridian. And here also like this. So this is going to be my zone boundary. Okay, so the zone boundary actually pointing towards the true north, and the Central Meridian is a straight line. Okay, the Central Meridian is pointing towards grid north. Is that clear? Okay, let's say I have a vessel here. This is my vessel and it is heading this way. The vessel is heading this way, say 045 degree. 045 degree true. What is going to be my grid heading? The same way, a vessel is here. Remember the latitude, how far away from the Central Meridian, how far away from the equator you are, that matters. So this vessel is also heading 045 degree, and that is true. So what is going to be my grid heading? Ready? So the true heading is like this and the grid heading is like this. For this case, the true heading is, because this is your true north, this is your true north, this is your true north, and straight line is your grid north. So straight line is your grid north. In the Northern Hemisphere, the true north is curving towards the Central Meridian. Okay, so now if you see on the right hand side or on the eastern half of the Central Meridian, the grid north is smaller than the true north. Visually, are you able to understand? This is the true north grid north angle and this is the true north angle. So the true north is always greater than the grid north when you are in Northern Hemisphere and on the eastern half of the Central Meridian, on the eastern side of the Central Meridian. But if you are on the west of the Central Meridian, then your grid north is always greater than your true north. Can you see that? Your grid north is greater than your true north. So as per that video that I have shown you, your vessel is in the Northern Hemisphere and on the western side of the Central Meridian. But what about the Southern Hemisphere? Exactly same. Let me draw the vessels. So this is a barge and this is facing 045 degree angle. This is again a barge facing 045 degree angle. So what is going to be my grid north and true north? Here you see that true north is going this way. So this is my true north and this is my grid north. So in the eastern half on the southern hemisphere, this is southern hemisphere, this is northern hemisphere. In the southern hemisphere, the grid bearing is greater than the true bearing. The grid bearing is greater than the true bearing. Here, this is your true north and this is your grid north. Okay, so here your grid bearing is greater than your true bearing. Or did I do wrong? Sorry, I drawn it wrong. Let me correct that quickly for you. So this is 045 degree. Your true north is going this way and your grid north is going this way. So your true north will be greater. Your true north will be greater than your grid north. Voila. I hope you understand the concept other than your quadrant that somebody used to tell you. I think visualization is much better. Here in the southern hemisphere, the true north is going this way and true north is going this way. In the northern hemisphere, the true north is going this way and the true north is going this way. It's curving, it's following the contour, following the exact path of the zone boundaries. This is towards the true north. This is towards the true north. So this is towards the true north in the northern hemisphere. This is towards the true north in the southern hemisphere. Okay, so if I draw a grid line here, you can see if the vessel heading is this way, your grid north will be greater than the true north. If I draw a line here and if I draw a vessel's heading, then you see your true north is greater than your grid north. Too much confusion. Let me refresh the drawing so that you understand better. Okay, give me 2 seconds. And 2 seconds is over. Now I want you to have a look at this drawing. Zoom in. You see on the northern hemisphere, in the east side of the Central Meridian, the true north is going to be greater than the grid north. In the northern hemisphere on the west of the Central Meridian, the true north will be smaller than the grid north. In the southern hemisphere, it is completely different. In the southern hemisphere, the grid north will be greater than the true north. When it is on the east side of the Central Meridian, when it is on the west side of the Central Meridian, the true north will be greater than the grid north. So my friends, tell me if it is easier for you to understand or not. If you think that this small snippet of videos gives you any value, please subscribe to my channel and give it a thumbs up, and please remember to share it with your friends. So I'll see you in the next video very soon. Till then, always be curious.